I've lost my mind doing this game, yeah. Like Vincent van Gogh. He dedicated his life to his art and lost his mind in the process. That's happened to me.
And here we are. So to just give a whole breakdown of our space and runtime complexity, so given the fact we're using dynamic programming and we are scanning throughout the different possibilities of the number of steps, or time complexity, starting off with that, is going to be O of n, where n is referring to the number of steps in constant time. And then for the space complexity, it's going to be O of n, as we're using an array to keep track of all of the following steps we have visited. Alright, and so this was Climbing Stairs. Thanks again for taking time to watch this. If you enjoyed it, feel free to like and subscribe. If you have any questions, feel free to put them in the comments section. And as always, take care. Cheers. We gotta pass all the test cases. And it works. Okay, so now just to give a rundown over a whole solution over what we have is that our time complexity for the following is going to be O of amount times n, where n is the number of coin types, and this can be for each coin, and we are calculating the exact value for all the amounts of what we've added up for the total. And the space complexity is going to be O relative to the amount, since we are using an array to store all of the elements that we have visited in our coins, and the amount of the coins is going to, the amount we need for our elements to be able to add up to the coin is going to vary because we need the fewest amount. So the bigger the amount, the more likely we're going to have to use more coins, which would explain our space complexity. So space complexity is O of amount, and time complexity is O of amount times n, where n refers to the number of coins. So yeah, this was Coin Change on C++ Leetcode. Thanks again for taking time to watch this. If you found this helpful, like and subscribe. And if you have any questions, feel free to put them in the comment section. And as always, take care. Bye-bye. We'll submit, and here we go. Alright, so just to give a rundown and breakdown of our time and space complexity is that, given the fact we're using a nested for loop and we're looping the array twice, the time complexity is going to be O of n squared, where n is referring to the size of the array, and the space complexity, given the fact we're using a data structure of an array to store all of the elements that we have found throughout the rest of the array, it's going to be O of n. So yeah, this was longest increasing subsequence. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe, and if you have any other questions, feel free to put them in the comments section. And as always, take care. Bye bye. Programming table to check for character and size of our text strings. And the steps for us to be able to go about this are for the following. So step 1, we're going to initialize a DP table with the size of text 1 dot size plus 1 times text 2 dot size plus 1 and when we do so, this is how we create our table. Then what we will do is that for step 2, we're going to loop through each character in both strings, and then for step 3, if the current characters in both strings are the same, the value of the current cell is 1 plus the value of the cell diagonally of the table, both above and to the left of it. And for step 4, if otherwise, if they are different, the value of the current cell is the maximum between the cell to the left and the cell above in our dynamic programming table. Finally, for step 5, we're going to return the value in the bottom right corner of the dynamic programming table we created to show the longest. Okay, and now just give a rundown on the space and time complexity for our following solution. Is that the time complexity for our solution is going to be O of m times. It's going to be O of m and it's going to be O of m and n, where m is the length of the first string and n is the length of the second string. This is because we fill up our dynamic programming table of size m times n, and the space complexity for our following is also going to be O of m times n for the same reason. And yeah, so this was longest common subsequence. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye. And just give a breakdown on the space and time complexity for a following solution is that the time complexity is going to be O of n squared times m, where that would be in the worst case, where n is the length of the string and m is the length of the longest string in the dictionary, and we use 2 loops of O of n to generate substrings, and for each substring, in the worst case, we may check a word of length m in the dictionary, while meanwhile the space complexity for a following solution is that it will be O of n for just in regards, since we're using an array to store everything. Alright, and so this was Word Break. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comments section. And as always, take care. Cheers. Bye-bye. Alright, passes all the test cases. Alright, and it works. So, to be able to give a breakdown on our time and space complexity, the time complexity for the following solution is O of n times m, where n is the target value and m is the length of the nums array that we have. And since we're iterating over the DP area once, this is why we have a constant, but we multiply, given the fact we need to consider both the length of nums and having n being the target, and the space complexity for the following, since we have an array and a data structure to store the elements we have visited, it's going to be O of n. And so yeah, this was combination sum 4. Thanks again for taking time to watch this. If you enjoyed it, feel free to like and subscribe, and if you have any other questions, feel free to put them in the comment section. And as always, take care. Bye-bye. Passes all the test cases, and it's pretty darn efficient. So, to be able to give a breakdown on what the time and space complexity is, so our time complexity is going to be constant, where n is representing the number of houses. This is because we iterate throughout the list of houses once. And then the space complexity is going to be linear O of 1, as since 1, we are not using a data structure to be able to store everything. We're just scanning throughout the array. And we're only using 2 variables to keep track of everything. So yeah, this was House Robber on Leetcode in C++. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe. If you have any other questions in mind, feel free to put them in the comment section. And as always, take care. Cheers. And so if we were to go over the example to help illustrate the point, I'll also have a visual in the video as well to help describe. So if we have a house, in this nums array, we have 3 houses with the amount of money 2, 3, and 2, and we need to find the maximum sum of all the following houses accordingly. And it looks like that we can only rob the house that has the amount of 3, given the fact that we were to rob 2 and 3, that alerts the police, and 3 and 2, that also alerts the police, because we can't rob houses that are right next to each other. You cannot rob any neighboring houses. No, that's why in this example, it looks like we can only rob house 3. And then also, if we were to figure out the index of this following number, if we were to visualize in particular on the houses that are around in a circular fashion, we cannot rob houses that are right next to each other, for this will alert the police, and this will also alert the police, and then this will also alert the police as well. But house 1 and 3, you cannot alert the police. And 2 and 1, you can alert the police, but the maximum sum is 3 and 1. So therefore, when comparing the different sums of each of the following combinations inside of our array, we get 1 and 3, which is 4. Alright, it passes all the test cases. Let's submit. Okay, now just to give a breakdown on our space and time complexity for our following solution is that the time complexity is going to be O of n, where n is referring to the number of houses that we have. And this is because we iterate through the list of houses twice. Well, meanwhile, the space complexity is also O of n, since we create two dynamic programming arrays with the size equal to the number of houses. So yes, this was House Robert 2. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye. That's all the test cases. Alright, now just give a breakdown on our space and time complexity for the following solution is that the time complexity is going to be O of n, where n is the length of the string. And this is because we perform a single pass through the string to fill up the dynamic programming array. While meanwhile, the space complexity for our following solution is going to be O of n, where n is referring to an extra dynamic programming array based on the size of n plus 1 to store intermediate results. And so, yes, this was Decode Ways. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye. See it. Okay. Alright, here we go. Alright, it passes all the test cases. So, to be able to give a rundown over exactly our solution and such, is that within our following solution, the time complexity is going to be O of m times n, where m represents the dimensions of the grid on the x-axis, and n is going to represent the dimensions of the grid on the y-axis. And then space complexity is also going to be the same at the same time, depending how large the entire grid is. Our space complexity is also going to have said complexity at the same time. And since we're also using a data structure of a vector, in this case, to keep track of all of the integers in the path that we have visited, this explains for our space complexity. So yeah, this was Unique Paths in Dynamic Programming for C++ Blind 75 Leetcode. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe. If you have any other... Alright, and we are good. And now, just to be able to give a rundown of our space and time complexity over what we have. So, given the fact that we're using a greedy algorithm, they're naturally pretty efficient in terms of space complexity because they just scan throughout the rest of the array. The principle behind it mostly focuses on finding every single possible element that we have in our given array or data structure. And since there's no data structure to be able to store any of the information that we have passed through, the space complexity is going to be linear, O of 1, while we are running on constant time O of n because n represents the size of the array. So yeah, this was Jump Game on C++. This is another subfield of dynamic programming as well. Thank you again for taking time to watch this. If you have any other questions in the meantime, feel free to put them in the comment section. And if you also like this, feel free to like and subscribe. And as always, take care. Cheers.